Let's take a look at projectile motion with uneven levels. In other words, it will not end up at the height from which it was shot. And what we're trying to do is figure out the optimum angle, and we're going to ignore air resistance because that makes life a little bit simpler. So I established my coordinate system, I hat, j hat. I know that once it is launched, the force acting on the object is downwards, and so therefore it makes sense to create a coordinate system that is vertical and horizontal, and I went for the traditional brainwashed right and up. So if that's the case, that it's going to go a range of r in the I hat direction, and in the j hat direction, it is going to end up below, given the way I've set this up, at a vertical displacement of negative h. It's launched at some speed v and some angle theta. I don't know what theta is in this problem. This is what I'm trying to figure out. And so I have v cosine theta as the horizontal and v sine theta as the vertical. And acceleration, I know that 0 and negative g are my components of my acceleration. If I plug into one of the cake formulas, and again I can because we're assuming that the change in height is not so extreme that g would change, and horizontally there's no air resistance, so there are no forces acting in the horizontal direction. And so plugging I hat and j hat into this, plugging the I hat components, we end up with r is equal to vt cosine theta and negative h is equal to v sine theta t minus 1/2 gt squared. Now for the sake of ease, the more I write, the more apt I am to make a careless error, and so I'm just going to let c equal cosine theta and s equal sine theta, and then later on I'll substitute in the function. So from that, this first equation here becomes r equals vtc. Again, c is cosine theta, and negative h is equal to vst minus 1/2 gt squared, and I'll call that equation 1 and equation 2. If I take that first equation and I can solve for t, I plug that into the second equation, and I get this, and you can just follow along as you take notes. From this equation right here, I'm just going to go ahead and cancel out my initial speed of v and square that and turn into a single fraction. If I multiply everything by 2c squared, that x there is for multiplication, multiply everything by 2c squared, the 2c squared cancels out on this side, one of the c's cancel out in that term, it gets the full 2c squared, and so we end up with this. Now putting in sine and cosine back in, and so we have a cosine squared and then a sine theta cosine theta. Actually, we have a 2 sine theta cosine theta. And over here on the side, just the quick derivation of cosine of 2 theta is 2 cosine squared theta minus 1. We're going to end up with a cosine squared theta, 2 cosine squared theta, that we will turn into that. And then sine of 2 theta is equal to 2 sine theta cosine theta. And so that 2 sine theta cosine theta turned into sine 2 theta, and then the 2 cosine squared theta I turn into cosine 2 theta plus 1. Next step is I multiply everything by negative 1, which gets rid of on this side and switches the order of the terms on that side. Distribute, and I'm calling that equation 3. I'm trying to find the angle theta so that r is at a maximum value. So instead of solving for r and then taking the derivative, we'll just take the derivative at this point. The math is just a little bit easier doing it at this point. So we have, well, h is pretty much set, r is the variable, v is set, theta is a variable. So dd theta, well, that's just a constant with respect to theta, and so therefore that drops out, and we end up with the derivative of this with respect to theta ends up being this. R is a variable, so that's why we end up with this dr d theta. And over here, we end up with a dr d theta. Actually, we end up with 2 terms. Because I have r and theta are both variables, so I end up with 2 terms over here. Now, I get a maximum range when dr d theta is equal to 0, because I'm trying to find the angle at which r is at a maximum. And so those terms drop out, since I'm now looking for theta maximum. So this is the maximum angle at this point. This is generic, and this is at the point where theta is at a maximum. Once we get to there, we can then solve for tan 2 theta, which is r over h. And so 2 theta is arctan of that, and theta becomes 1/2 times the arctan of r over h. We'll call that equation 4. So if I know r and h, I can find theta. So looking at the right triangle there, I know the tangent of 2 theta is equal to r over h. That's where we had started earlier, and so I have r over h with an angle of 2 theta there. The hypotenuse would therefore be the square root of r squared plus h squared. And then we also, once we've established that, cosine of 2 theta and sine of 2 theta comes straight from SOHCAHTOA. We take these and plug it into our equation 3 right here. We get the squared terms on one side, the unsquared terms on the other, and we end up with r squared plus h squared over the square root of r squared plus h squared is equal to gr squared over v squared minus h. Again, this is the height of the cliff. R is how far out it goes. G is acceleration due to gravity, and v is the initial speed. And from that, we end up with the square root of r squared over h squared. In other words, the hypotenuse of that triangle is equal to this. I square both sides to get rid of my radical. I end up with that. I subtract h squared from both sides. Matter of fact, just cancel it out. I'm now with this. If I divide by r squared, since every term has an r squared in it, I'm left with 1 on this side. Over here, the r squared goes away. I'm left with everything else. And here, the r to the 4th becomes r squared because I got rid of 2 of them. Just changing the order around, so adding that to both sides and then just flipping the order in which I write it. Multiplying both sides by v to the 4th over g squared. Taking the square root of both sides. Now I'm going to let r sub naught be v squared over g. That is how far an object will go if it returns back to the same level. That's sort of the maximum distance if you shoot at a 45-degree angle with no air resistance. And so r is equal to r sub naught times that. We'll call that equation 6. We bring back equation 4. And I just break r over h into this. So notice if I multiply them together, the r sub naughts would cancel out, and I'm left with r over h again. I'm going to plug this in for r, because the r sub naughts will cancel, or r over r sub naught is the square root of 1 plus 2 over 2h over r naught, times r naught over h. Multiplying the two fractions together, multiplying the numerator, multiplying the denominator, I'm left with this. Now, if I look at my triangle here, the arctangent of this relationship is half the angle. In other words, 2 theta is equal to the arctan of that, or tan of 2 theta is equal to this, equal to that. In other words, if I have a triangle here where that is the opposite side and that is the adjacent side, then this holds true. And my hypotenuse would be square root of that squared plus that squared. And if you work all that out, the hypotenuse of this triangle is just h plus r sub naught. So theta becomes 1/2 the arc cosine of h over h plus r sub naught. Or I could do it in terms of secant. And depends upon, in what form do I want it. Now, notice that as h goes to 0, so it returns back to the height at which it was launched, then we get 1/2 a cosine of something that approaches 0. A cosine of 0 is 90 degrees. 1/2 of that is 45 degrees. So as h goes to 0, my angle gets closer and closer to 45 degrees. And again, reminder, r sub naught is just the speed squared divided by g. So we now have formulas for the angle to get the maximum distance. And let's compare it to what Wikipedia has, because if you go to Wikipedia, the formula is a little bit different. And so the formula that Wikipedia gives is this. So let's see how that compares. So y sub naught is the same as I was doing for h. And so just making that substitution, since theta is a cosine of that, cosine of theta must be just that piece. Factor out g from the square root, and it reduces down to this. Because again, I got this v squared over g, which is just r sub naught. Square both sides, cosine squared is 2h plus r sub naught over 2h plus 2 r sub naught. Multiply both sides by 2, 2 cosine squared is equal to this. Subtract 1, get a common denominator, and simplify. So we have 2 theta is a cosine h over h plus r sub naught, and ultimately we end up with what I had derived on the previous page. So what Wikipedia has and what I have are the same thing. And that sums it up.